I'd like to introduce the work on plan repair in Shop 3 that Ugur Kuter, Rick Freedman, and I have done at SIFT. Shop 3 is our descendant of the University of Maryland's Shop and Shop 2 planners, and like them, it is a lifted, forward, state-space planner, and it's freely available on GitHub. Our motivation in this work was to provide stable plan repair for plans and execution in applications based on Shop 3. Plan repair has been shown to be a better way to react to disturbances in plan execution than replanning from scratch. It can be more computationally efficient, and it can produce modified plans that retain more of the structure of the original plans. This has been called stable plan repair by analogy with control theory notion of stability. Stable plan repair is particularly important in interactions with users who can be confused when relatively modest changes in the environment cause radical changes in the plan. Our contributions in this work are as follows. First, we extend previous studies of the stability of plan repair by Maria Fox and her colleagues by measuring stability of plan repair with disturbances in arbitrary positions in the plan. That original work, while very important, only examined replanning and responses to changes in the initial state before execution begins. In order to do this, we developed an extension to their LPG repair to make such plan repairs possible. Second, we show how to use normalized compression distance to evaluate plan stability and show that it's more discerning than the more commonly used action distance, particularly because it doesn't treat actions as atomic. Third, we provide a new algorithm for plan repair in the SHOP family of planners, which we've implemented in SHOP 3. Like previous such algorithms, it relies on causal links, but unlike them, we show that our repair algorithm is sound and complete, and that it can repair HTN plans with quantification and conditional effects. Our algorithm relies on a failure detection method that is complete but unsound. It can have false positives. So it gives a conservative over-approximation of the set of plans that need repair. Finally, our algorithm uses backjumping to rapidly find repairs. I'll just give a quick review of our experimental results. First, we wanted to make sure that our broader notion of plan repair didn't upset the earlier results that showed repair was more efficient than replanning. To do this, we did experiments with both our system and our enhanced LPG repair. Indeed, the results confirm a substantial increase in efficiency for both planners, but the difference was more pronounced for our method. Second, since our method relies on additional bookkeeping above normal shop planning, we did experiments to measure the runtime costs of this additional bookkeeping. Because if this bookkeeping cost was excessive, it would undercut our claim that our plan repair is more efficient than replanning. Our experiments confirmed that the cost of the additional bookkeeping was negligible. So far, we confirmed the results on efficiency and shown that they apply to our method as well as that of Fox and her group. Now we want to look at the question of stability. Here we argued that stability was better measured by our NCD metric than by action distance. Better measured is subjective, but we showed experimentally that NCD provides much more tightly clustered measurements than action distance. In other work, we have also provided more results on the comparison between NCD and action distance and other plan difference metrics, including examples that show greater agreement with intuitive notions of similarity. Finally, we present experimental results that show much greater stability, fewer changes, from plan repair than replanning, again for both our method and the enhanced version of LPG repair. I'll close with a couple of future directions. First, we will extend our method to cover domains that use more of the expressive power that SHOP provides. And second, we will use analogical replay to further improve the stability of our plan repairs. Thanks, and I hope you'll come talk to me at the poster session.